Consider a particle of mass m and charge q in an electric field E. Its potential energy is given by minus q E x. Consider a path x naught of t equal v, a constant times the time t, between events. Calculate the action for the path x naught. We know that the action is the time integral of the Lagrangian between the two events, and the Lagrangian is the kinetic energy minus the potential energy, and we can express. So we have to express this kinetic and potential energy, and we get. Second question: show that this path x naught is not the stationary path. To do that, we need to calculate the action for a path with a small change around x naught. If we can show that A is non-zero, then we have proven that x naught is not a stationary path. It is much easier to show that a path is not a stationary path than to show that a path is the stationary path. So in this case, we can simply pick up a function n, which work well for us, and show that indeed in this case a is not equal to 0. So n is in principle is arbitrary, but we need to make sure that n is equal to 0 at the initial and final event. A possible function will be a sine function with a period such that n obeys these initial and final conditions. So we now calculate the action explicitly for this new path. So indeed we see that term linear in epsilon is not 0. Therefore we have shown that x naught is not the stationary path.